Good afternoon, guys. It's Sir Gerald again. Let me just check if we're recording. Okay. Uh, Again, we're here for Month Zero, wherein we'll be continuing on our discussion regarding some topics regarding geometry. And for today, actually, we will be talking about lines. Wherein by lines, these lines are special lines, and we actually call them perpendicular lines and equilar lines or line segments. And also on the other half of that, we will be also talking about parallel lines. So what's special or what's so special about these two lines? By definition, when we talk about perpendicular lines, these are intersecting lines wherein the intersection of these lines or two lines actually have an angle of 90 degrees. So let's say if we have a line here, that line, and we have another line, which is this one. If we are to say, by the way that I have drawn these lines, if we are to say that these lines are perpendicular, it just means that these lines meet at an angle which is actually 90 degrees. Meaning to say, this angle here is 90 degrees, this angle here is 90 degrees, and another angle here is 90 degrees, and another 90 degrees. Okay, so for the parallel lines, if we have here another line here and another line which is located here, just write that. Okay, so if we have here, if we are to say that these two lines, the black line and the red line, is actually parallel lines, meaning to say, at any extent or any, if ever we extended these lines, they will never meet. Okay, that's why they are called parallel. They just go along with each other, but they will never meet. Okay, so in that, actually, we can actually check whether a line is perpendicular or not. There are some cases where lines intersect. Say we have here this line and this line. On how I have drawn this line, we can say here that it is neither parallel or perpendicular. So these lines are not parallel or perpendicular. So again, in analytical geometry, we can actually check whether intersecting lines or non-intersecting lines are perpendicular or parallel. So it has something to do with the concept that we have already mentioned during the basic concepts of uh, analytic geometry. So it has to do with our notion of slope. So by slope, we know that slope is just the change in x or change in y over the change in x. So we represent that slope with a letter m, which is actually computed using the change in y over change in x, or uh, in our in layman or narrower sense. So that will be y2 minus y1 all over x2 minus x1. So how can we use this slope to identify whether a line is perpendicular or parallel? For perpendicular lines, if we are to say that this line is line A and this is line B, okay? So comparing the slopes of perpendicular line, say the slope of M is A, line A and line B must be perpendicular when the slope of line A is actually equal to the negative inverse of the slope of line B. And for parallel lines, since they will not meet with each other, if we are to say that this is our line A and this is our line B, lines are perpendicular when they have the same slope. Meaning to say, the slope of A is equal to slope in B. So what happens if the slopes or the if we are comparing the slopes that does not mean these conditions, meaning to say those lines are neither uh, perpendiculars or parallel lines. So why do we need to use this slope? We will see that later. So in that, let's have here some examples. So I have here four lines. So by looking at it, we can actually assume that these lines are actually parallels and perpendiculars. Meaning to say, if we are to look at line AB and line CD, we say that they may be perpendicular, and for line GH and line FE, we can also say that they may be perpendicular. Okay, correction. AB and CD are parallel. So, on that, how do we write that? If we are to write or we are to assume that AB, line AB is parallel to line CD, we just write that as this. So we just write A, B, we write a bar over AB. So parallel. So we just use this double line here that looks like number 11, but it's not. So that's the symbol of parallel. And we have their CD. So for this one, uh, we can, for perpendicular, we can write it as line EF, or line segment EF is perpendicular with line or line segment GH. So for that, we can just assume that it's true. Okay? So we actually need to compute for the slopes to be sure that they are parallel or perpendicular. So for the AB, we need to show the TS that line segment AB is parallel to line segment CD. So in that, let's first compute for the slope of line segment AB. So in that, like I said in the earlier slide, we just need to compute that by getting the change in Y over the change in X. So if we have here point A, which is negative 7, 1. So we have here change, and B, which is 1, 6. So we have here 6 minus 1, that will be our change in Y, over, we have here 1 minus, we have here 1 minus negative 7. So upon computing, we have here that will be 5 and this will be 8. So on our assumption, if line segment AB has a slope of 5 over 8, line segment CD must also have a slope of 5 over 8. So in that, let's have here the slope of line segment CD. So we have here C, which is negative 2, negative 6, and we have here D, which is 2, 3. So for the change in y, we will have here 3 minus y. So negative 2, okay? Then that will be over, we have here 2, and we have here negative 6 minus negative 6. So that will be positive 2 plus 3 plus 2, that will be 5. And we have here 2 minus negative 6, that will be positive. So 2 plus 6, that will be 8. So as you may see here, the slope of line segment AB is actually equal to the slope of line segment CD. Meaning to say, uh, thus, so we have here our therefore sign. Therefore, line segment AB is actually parallel to line segment CD. So let's try this one. So checking whether line segment EF is actually perpendicular to line segment GH. So assumption again, remember, we need to show that line segment EF is perpendicular to line segment GH, meaning to say the slope of a line segment EF must be equal to the negative 1 over uh, tawag dito, 1 over uh, the slope of line segment GH. Okay? Let's first compute for the slope of line segment EF to confirm whether they are perpendicular or not. So, EF. Change in Y first. So we have here that will be negative 5 for the Y in E. And we have negative 1 in F. So we have here negative 1 minus negative 5. Okay. Then we have here for the x's, we have here F as an x of 5. We have here 5 minus x of E is 7. So 7. So we have here that this will be positive. So negative 1 plus 5, that will be 4. Okay, and we have 5 minus 7, that will be negative 2. So that will be equal to negative 2. Okay. On this assumption, if we are to compute for the slope of line segment GH must have a slope of 1 half to confirm this. So how do I know that? So based on the assumption, if we are to use the negative 2 slope of EF, we just plug in that that negative 2. As you may see here, this will cancel out. GH must be 1 half. Okay? So let's try for the line segment or the slope of line segment GH. Let's get the change in Y. Change in Y will be H is negative 1. Okay? G is negative 5, so minus negative 5. Okay? Over change in X. So X of the X here will be 8. So that will be 8 minus the X of 8, G, which is 0. I have here 0. So as you may see here, this will be positive. Okay? So negative 1 plus 5, that will be 4. And we have here uh, 8 minus 0, which is 8. So this will be equal to 1 half. Okay? If you want to cross-check whether your answer is true, if you are to plug in the slope of EF, which is negative 2, in this formula, so we'll have there negative 2 is equal to 1 half here. So we have negative 1 over 1 half. And by rule of division of fraction, we will have here an inverse wherein we will have 1 times 2 over 1. So we will have there 2. Let me just show that. We will have here 1, negative 1 times 1 times the inverse of 1 half or reciprocal of 1 half. So we'll have here 2 over 1. This will be 1 times 2. That will be 2 divided by 1. That will be 2 times negative. So we'll have here negative 2 is equal to negative 2. And as you can see here, it is equal. So since the slope of a line segment EF is equal to the negative inverse of M or the slope of GH. Therefore, line segment EF is actually perpendicular to line segment GH. So that is how we assure or we check whether intersecting lines or non-intersecting lines are actually perpendicular or parallel, respectively. So for the parallel, we need to check whether their slopes are equal, and for perpendicular lines, we need to check whether the slope of one of the lines is actually equal to the negative inverse of the other one. So that's it. That is how you check whether lines are parallel or perpendicular. So for your exercise, I may need to you I may need you to check whether these lines are actually perpendicular or not. You need to check whether uh, line segment line segment IJ is perpendicular to line segment KL. And also, for this one, you need to check whether uh, line segment MN is actually parallel to line segment OP. Okay? So again, I will be giving you a submission bin for this one. So go check out our Edmodo page. In that, bye.